Okay, how's everybody doing tonight? Everybody get logged in. Hopefully see my monitor, my Mac here. I'll wait for everybody to get in. While you're logging in, make sure when you enter in the website and that code, click the web button, which is at the bottom button, I believe. You don't need to download anything. If you're having to download something, you click the wrong button. So just click back and restart it. You will prompt you to download something if you hit the not the bottom one, but the one above it. You want to click the bottom green where it says join via web browser. That's the one you want to click on. So yeah, you want to click on that one after you enter everything in. Good. Okay, so now we're going to go over chapter 2 content and then do a group lab. And all right. Well, first thing I want to go over is there is posted as of today. You can start registering for the RBC Tech Expo coming up on 10/23/2018. 54 days, 22 hours, 26 minutes, 54, 53, 52 from now. This is for you to discover tech careers, network with tech firms, and win tech gadgets. What tech gadgets are we referring to? I'm glad you asked. Let's go there and find out. So we're going to be giving away this year, we'll have it on here, but 3D printer, iPad mini, just to name 2 items. And this is the 3rd year. We're going to have a keynote speaker from here locally in Rockford Workplace, Michael King, who's worked with Lorraine Logan, which is a city leader. Lorraine was invited to speak, but she asked that Michael speak in her stead. I invited her personally. I've been on a number of committees with Lorraine, and she is a person in town that really wants folks to get hired locally and regionally. And so, hey, how you doing? And so, but Michael's a great guy. He's been here before at this what you're seeing on the background there on that website. Stephanie's right there, one of our instructors. Eric's behind her. Last year, I believe we had 89 in attendance. And businesses will continually give us stuff to give away, so we'll have more than what I just mentioned. But Mike's going to speak on items referring to that you're hopefully interested in, which is basically the jobs in the future. And let's see if I can go to that section here. Let's go to speakers, and there we go, speaker bios. All right, he's going to talk on need for skilled IT workforce in Rockford region, and he's going to be speaking from 6:05 to 6:30. From 6:30 to 7:50, I believe. Let's see the agenda here. Yeah, 6 to 6:05 is the intro, 6:05 to 6:30 is Mike. Connection time is where you'll visit tables. There'll be local businesses there, then in the IT area, from general IT to programming and networking, RBC Career Services, resume building, job connections, CIS faculty, along with about 12 businesses that will talk to you about internship possibilities, everywhere from Ingersoll to Entree to Woodward Governor in town will be there as well. And so it's a good event, worth your time to go. So now RSVP so you can mark it on your calendar. Questions about Tech Expo? Okay, the other thing I want to mention is of code. I think I mentioned this last week. I'll mention it again. rbchourofcode.com. If you're interested in attending, you can go to the RSVP section of hourofcode.com, and there is coming up this next Tuesday is Build an iPhone Game. In October, it's the first Tuesday of every month, Intro JavaScript. November, create a game about the movie Frozen. And we always do in December, being holiday month, create an animated holiday card. So you can come and attend, or you can come and help. If you want to help, you can click on the RSVP and go to help area and just fill out this form here that you are interested in helping. And the last website I'll mention is myrbc.org, which is our division website. Here's where we post information about events, connect to an advisor, connect to jobs. So if you've not yet bookmarked that, definitely do so. You can also follow us on Facebook, Twitter, and download our iOS and Android app. Also go over certificates that we just recently put in play was the network technician and the mobile app developer, those two. And you get to see some of the event pictures and stuff like that. So this week, I'm going to go and click on syllabus. Lab 2 we'll do tonight after our discussion. Review questions for chapter 1, which remember is the in your text, your PDF. After you read chapter 1, in the back of chapter 1 is some questions. I just need the answers only submitted. Research paper topic. We went over that briefly last week. I turned that in by Sunday. I had a few of you email me and come by and ask about a topic. So I'll know you're thinking of it already. So that's good. So just finalize your idea. I think I mentioned last week to pick a topic that you know a little bit about, but you're interested in the topic, right? That's going to be the one you really get a lot out of, hopefully, when you're researching it. And then quiz for week 2, chapter 1, Introduction to Networking. 3 opportunities to complete that and get the highest score out of 3. Now, just an FYI, I've not had too good of a day today. I usually don't bring my personal life to work, but my wife's brother is turned for the worst, and so I've been with her pretty much all day. And so if I'm a little bit non-cheery tonight that I normally am, that's why. So just bear with me. And so, but he is keeping him out of pain, which is good. And so she'll be heading there tomorrow. So if I'm not my normal chipper self, that's why. Okay. So let me go here to my, and by the way, I do have the, in our course, I did put the weekly slides in the course documents you can look at later when you get home if you want to. Since you're seeing it in front of you, you don't really have to do that. And so let me go to that one here, make sure this is week 5 or version 5. Let me make sure that's the case. Yeah, okay, cool. All right. I want to go. Let's add that. Minimize that. Okay. There we go. So we're going to look tonight at some of the objectives for the chapter, which is basically talking about client server, what it's all about. We'll look at some examples of basic networking, and then we'll go right into the lab, which I already have. You'll get a handout with 3-hole punch. If you did want to put that in a binder later, you may do so. So why use networks? I'm glad you asked. Basically, just a network is a group of computers connected together by some media. It could be Cat5, like these computers here. in this room, or it could be Wi-Fi, could be through wireless, could be Bluetooth, USB, number of different infrared. Standalone computer, that's basically what most of you use at home, a computer connected by itself. But technically, in today's culture, even though you have a standalone computer, you're generally always connected via the network, whether it be on your Wi-Fi network at home or at work or on your phone, you're connected to a network. A standalone computer is generally, though, when it comes to software, not connected to other computers via software. And just so generally have all your software located locally on that computer and all the data. The advantages of networks over standalone is the fact that you can share data to a group of users like you can do in a workplace, and you can manage things from a central location. Meaning I can control everybody's computer and push updates to them from one location. You literally could be in California and I could be here in Rockford, and we could be doing the same thing we're doing tonight, actually, and with no difference really, except we're not in the same room. And so that's kind of cool. And so types of networks depend upon, you'll play around this tonight when you do your diagram, and I'll see how artistic every group is tonight. That'll be kind of fun to see if we have an art person in every group or a leader. For sure, I'll definitely know who the leader is really quick. And then also second to who likes to draw. Those two things usually. And if you don't like to draw, it's no big deal. Somebody in your group will. So computer positioning, controls over shared networks or shared resources, communication over shared schemes, which would basically be like rights and privileges. And then there's two models. One, we went over this, I think, last week in the Kahoot, is peer-to-peer and client-server. Peer-to-peer basically is where I'm connected to you, you're connected to me, and nobody else is connected, right? Client-server is, I'll pretend I'm a server, and everybody in here is clients, and you're gathering all the data from me, kind of like you're doing tonight with viewing my Mac on your computer. I have it on my desktop here, but you're viewing it on your clients. Peer-to-peer network is direct communication, equal authority. Nobody has any more rights than the other. I can share stuff with you. You can share stuff with me. The problem with that is if I leave or I get sick and I have data you use every day, that's not a good thing. And so that could be a problem. But for small shops and things like that, it works pretty good. Individual resource sharing. On peer-to-peer, you may share resources, may prevent people from accessing certain folders. Traditional model is generally 2 or more, maybe 3 computers at the most, connecting to one another to transfer data. And you can connect via a lot of different means. You can connect wirelessly, you can connect via Cat5. Here in a few weeks, we'll do crossover cabling and straight through cable. You can connect via crossover cable. And you can connect via Bluetooth, which most of your computers have. So here's what a diagram of basically resource sharing in a peer-to-peer environment. Again, everything's on the same playing field. Nobody has more rights than the other. And it's very simple, not real complex, and easy to set up. So very simple, cheap to set up. A disadvantage, it's not flexible, can't grow too much, and not for larger installations, and not very secure. So in the peer-to-peer model, you can share resources, and it's a user's responsibility to do that. It's not centrally controlled. Every person has to control their own computer. So good places for this would be like small offices or large networks like peer-to-peer you might have heard of, like Nella, Freenet, Napster, which is way back when, and BitTorrent, which is a new one on the block with the last 4 or 5 years. And even Microsoft uses BitTorrent. Apple uses BitTorrent. When you go to download a file from these folks, or Dell, it's going to use BitTorrent to download. And all that means is basically you've got, say, an update you want to download, right? So instead of downloading it from one location, BitTorrent allows you to download it from hundreds of servers, that same file. And then when it comes down to your client, it puts it all together. So it breaks it up into thousands of different pieces. And then the BitTorrent software can put it back together in one nice file. So what that does is relieves the stress off of any one server and load balances it amongst multiple servers. And you might have had this happen at home. Maybe you've downloaded a file and it starts downloading very quickly. Anybody had that happen before? Download very quickly. And then about 2 seconds later, it's downloading very slowly. You had that happen before. Okay. More than likely, the server is the one throttling that download, not you at home or your IP provider. And so we'll talk about what that's all about this semester and why that is and the purpose of that. So going on with client server networks, we just talked about peer-to-peer. Client server, you got a server, and servers are generally used to facilitate communication, shared resources, authentication. Clients would be like personal computers connecting to those. They used to be known as workstations. The central resource, also available by a server, is where you can connect to databases, stored your own personal drive on a network with limited or unlimited space, and no direct sharing of client resources. Meaning, if everybody was we were in one company called ABC Company, and everybody was connected to a database to do your work. If your computer was to crash tonight, all we would have to do is give you a new computer tomorrow and you'd be right back in business because the data you're working with every day is on the server, not on your client that you're working on. So it's easy to replace a computer. It's very difficult to replace data, near impossible if it's not been backed up properly. And you'll learn of ways you can restore data if you do lose it or you corrupt it or it's been deleted. But networking in general takes your data on a daily basis and backs it up all the time, whereas your local computer does not do that. So some roles in networking and client server is computers role. In the roles there, you got servers, clients. They run local applications, store local data that's not critical data, use server shared applications, server shared data and devices, and uses a server as an intermediary device between communication. And then a communication tool, like on everybody's table, at the end of your table against the wall, is some switches. Those switches are what connects you to the Cisco network server, which is in the other Cisco lab. And so when you log in and connect to, you get internet access, you can talk to one another all through that server that's in the other lab. Here's a client server architecture. You'll notice a difference on the peer-to-peer, everything was the same, right? But you'll notice on this one in the middle is a difference, which is this go-between device, this connectivity device. And you'll notice it has illustrated here, crudely here, some Cat5 cables running from each computer into the NIC card, even to a printer, to where all these computers can now print to the printer. They can share files one to the other. They can share files to the server. And if this computer was to say crash, we can just replace it with another one and keep our work going. So server requirements, a lot different than client requirements. Because it's so intense in its resource, it needs a totally separate operating system than what you have as a client. So it doesn't have Windows 10, Windows 7, Windows XP, does not have Windows Vista, any of those operating systems you might have had in the past. It has its own network operating system. And Microsoft is called a Microsoft Network Operating System. And the acronym is NOS, Network Operating System, meaning it's uniquely designed to manage multiple data, multiple clients, controlling multiple users, multiple devices like switches and computers, and telling rules, setting up rules to communicate. Examples of servers, I already mentioned Microsoft, but you also have Unix, Linux, Mac as the other top three. The top three actually in this mix would be Linux, Microsoft, and Mac. Unix is still around, but not as popular as it used to be. Universities, NASA, government entities still use Unix for older antiquated data that they've yet not merged over into one of these other platforms. And it'll probably be like that for a while. Server features relative to clients has more memory. An example was, say your memory at home at the computer is 12 gigs, let's say. Save 12 gigs. Not uncommon for a server to have close to a terabyte of memory if you have the right server with the right components. Also, you can have more processing power because instead of one motherboard, you can have 32 motherboards daisy chained together for one server. And so much different in the processing power. Storage capacity. Instead of one hard drive, you can have what's called a RAID drive that can have terabytes of data or petaflops of data, which is a huge number of data. And so what you just can't and don't need, it's overkill, right, for end users, but for servers, definitely need it. It's equipped with special hardware that allows it to function and manage networks. Disadvantage, it's very complex in design, and the maintenance is constant on a daily basis for servers to keep up and to stay clean and healthy and vibrant. It needs a lot more care than just a normal client operating system does. And one of the reasons, big reasons, is there's so many connected users to that server doing a lot of different processes all day long. Not just one computer, but hundreds of computers, even thousands of computers. Imagine a company like JCPenney as an example, or Sears. I worked in Sears going through school in sales, and we literally were connected, I know, to thousands of computers to one network on a daily basis. And was not uncommon to get updates and things like that from the server to the local clients on a daily basis. But need a large team of people to do it. So client server advantages, again, over peer-to-peer. User is assigned from one place, credentialing, meaning when you log into a server here in the classroom, you're actually logging into your local computer with your login. But when you're logging in downstairs or you're logging in anywhere on campus, you're logging into the network on RBC's network, which is in that little room to your left when you walk out of here. It used to be open, the glass used to be, where you guys could see all the servers. At the end of the semester, we do a tour, by the way, of all the servers in there. And for a bit, I was over the IT department here, and so I think with the last count, we had something like 124 servers in that room, and it's probably increased since the count I had. And so it's kind of cool to see how servers are in there, where they're stored, how they function. But when you log in anywhere on campus or even at home, you're logging into that room there in one of the servers. Yeah.
I thought that campus on Samuelson, ain't that the main server?
Nope, this one is here.
Oh,
yep. Yeah, Samuelson actually logs in through this one as well. Oh. Yeah, but they are connected. You're right. They are connected to this campus. Also, multiple resources can be stored. Central problem monitoring, meaning I can monitor. There's actually a monitor, multiple monitors in the IT department where they monitor every server, every computer connected to the network, and they can see the health of it, diagnostic and correction capabilities. User response time is much quicker because you can literally right-click on any computer or server, and you can restart it. You can remote control it. You can push updates to it. A lot of cool things. It's efficient on large networks and very scalable. If we want to add another classroom or a building, like the nursing building we added here recently, yeah, we just basically ran wires under the ground. There's actually in the ground here in Rock Valley, under the ground, multiple tunnels, big enough for golf carts to go through, that runs all of our fiber cable from building to building, including the new nursing facility, which is pretty awesome. I know the guy that works down there. I don't think he's ever came up in a number of years. No, just kidding. He does. And so, but it is a pretty cool play. It is a pretty cool thing, I think. I mean, a lot of people, might be claustrophobic down there, but I think it's kind of cool. But popular in very, medium and large scale organizations. Client servers are. And you guys have worked in them for years probably, and you just didn't know it, and you're going to learn a little bit about it this semester. So one of the first terms we'll look at is LAN, local area network. Now, when I was a high school teacher, anybody remember the term LAN party? Anybody remember that one? LAN party is where guys and gals used to bring desktop or usually laptops and switches to a room like this, and I would teach them how to connect their computers to the switches, and they'd play games like Quake and Counter-Strike, right, for hours on end, right, literally. And it was so funny whenever I would, in high school, the deal was I taught C++, and they had to complete like 3 Counter-Strike maps during the semester. If they completed in C++, the Counter-Strike maps, they'd pick a Saturday, I would buy pizza, and they get to bring in their switches, and I'd bring mine in and show them how to do it. And they, play Counter-Strike all day. But what was funny was the room we were playing, the computers were against kind of like a horseshoe kind of thing, right? And they'd all bring their headsets in because, you wear headsets to talk to one another. What was so funny was they're in the same room, okay? Literally feet away from each other. And you got team here, you got team A, team B, team C, whatever. They have different names that they would call them. And they say, okay, Joe, make sure you're the sniper. You get on the roof. You go over there. Okay. The team B's right here. And they've got headsets on and they're talking to each other. Do you get that? Yeah, I got it. And I'm like, okay, he can hear you. He's like 2 feet down. But anyway, LAN parties was huge in the 80s and 90s. And I think it still is a little bit today, but not as much as it used to be probably. Because you can do it all on the internet now. You can do, connect to a network and do it quicker or just as quick probably. But it's kind of cool to do it, I thought. You kind of get to learn some stuff, and you isolate a lot faster, by the way, because you're in one room and there's no bogging down of the network because you're no latency, very little latency because you're all, in one space. So networks are confined to relatively small spaces, like this room here is considered a LAN, okay? In the 80s, with the movie Hackers, which I recommend watching, I think it was Angelina Jolie and the gentleman who played, or who does play, I believe present day, was it Sherlock Holmes? Is that right? Sherlock, I think. What's the name of the detective? I think it's Sherlock.
Which one?
What is it now?
The one on TV? Or
The one on TV, yeah.
Benedict Cumberbatch? Or
No.
Robert Downey Jr.?
Yeah, no, it's the series. It's a TV series.
The old series.
Yeah, it's a new series. It's out right now. It's got Lucy Liu, and she's in it. And
Oh, yeah, Lucy Lewis Watson.
Watson, there you go. Watson, who I was thinking of. Anyway, around that genre there is when it became real popular. But those two, the guy who plays Watson and Angelina Jolie played that Hackers movie. I recommend watching that. But anyway, in that one, they kind of over dramatized LANs back then, but it was kind of a cool movie anyway. Definitely a cult movie for sure. Today, though, LANs are popular because of complexity in networks and companies across the U.S. and abroad. So next one after LAN, a LAN again would be like this room, okay? And each room in the building here is connected to an individual LAN. So we could say every room in the building is a LAN, and then the entire building itself could be considered a local area network as well, connected one to the other, each room. Next is a MAN, metropolitan area network. This is where network extends building boundaries. So WTC connecting to JCSM, CL1, CL2, PEC, maintenance building, nursing building, all via the tunnel I mentioned earlier, the Cat5 tunnel, right? Or the fiber optic tunnels going between the buildings. It's larger than a LAN, but it's connecting each LAN one to the other. And next is what this looks like is MAN, LANs, and WANs. Now, we went over LANs, MANs. Now, WAN is a wide area network. And when you think of a WAN, you want to think of internet, okay? The internet. You'll see on this diagram the internet cloud, and you'll notice the WAN link. we'll talk about Stenstrom. That was already mentioned earlier. We'll pretend this is Stenstrom here, okay? On Stenstrom's campus, there's a router at the end of that campus. At the end of, we'll call this the pipe of that campus here. There's a router. It's connected to, I think we're on Illinois CenturyNet is the name of our ISP, our net service provider. And so ISP, Illinois Century Network, has a direct line from the campus on Stenstrom to the Rock Valley College campus, okay? So here's a router here. And by the way, you'll learn more about that this semester. Routers are literally defined as the first line of defense. There's rules set on routers that blocks things coming in and going out of the network. So we have Stenstrom here on the left going to Rock Valley College campus here on the right. And then these we'll pretend are the buildings here in the network. We can pretend maybe this is our building, WTC, this may be JCSM, and maybe CL1 or something. Right? But you'll notice how each one of the buildings or rooms, we can say on this side, has a switch connecting all of the computers, switches and hubs. But generally, building to building, you're going to have routers on each one, at least one in that router section or in that building section. So like here on campus, we have a main router that hits this building for all of our telephones on campus, for all of our networking. And then the fiber cable that runs underground goes into a fiber connection switch in each room or each building at the ground level. From that ground level switch goes floor to floor connectivity from switch to switch to switch to switch, okay? Most switches have about 24 port connectivity, and each switch can be configured. We do have classes here on campus in Cisco that teaches you how to configure those switches with rules determining IP range, determining where things are routed to. And so might be something to think about while you're on campus is taking some Cisco courses, getting Cisco certification. It's a great money saver taking it here on campus, and Cisco's the #1 network provider in the world. And so they're not going anywhere anytime soon. Okay. Next is talking more about the wide area network, connecting 2 or more geographical distinct LANs or MANs. Comparison to LAN is basically a larger distance for sure, and slightly different media transmission, meaning instead of using Cat5 like we use in this room, or fiber like we use building to building, they might use like T1 is a term you'll hear this semester, and what that's about, or T3 or T5 connection. These are very large pipes that allow large amounts of data to be pushed through between point to point. And so same concept is larger and bigger technologies. Network connection on a WAN generally is going to be coming in separating offices in the same organization, or maybe separating offices in different organizations. So in this campus, we are using network connection building to building on this campus with switches, okay? But from this campus to the Stenstrom Center, it's router to router, okay? From this campus to Bell School campus, router to router. And just kind of keep that in your mind, that when you're connecting different locations via a WAN connection, it's going to be router to router and connected via the internet of some type. It could be Xfinity, it could be the ISP like we use, which is the Illinois Century Network. So here's a crude drawing of a simple WAN. You notice we've got the internet, WAN link, connecting router to router to connect connection B to connection A, or location A to location B. So elements common to client server. In the client, you have the network requesting information from every computer all the time. Literally every millisecond, they're knowing where everything's at and where the best path for data to go. The client is working with you as a human, right? Typing in, searching stuff, doing your work at work. And the client also has software installed for you to get your work done, like Word, Excel, Access maybe, Dreamweaver, Adobe Photoshop, Adobe InDesign, whatever it is your work, AutoCAD, Visual Studio, Android Studio, whatever it is you're doing at work is a client software connecting the data generally on the network for when you leave at night, data is safe and secure on that network somewhere. The server, basically shared resources, already mentioned. Data mainly is your shared resources. So all human resources, all of marketing, all of sales, all of student records, all of student data, all stored on shared resources on the server and backed up every night. And you'll find out this semester we talk more about backups, but we back up on campus that are backed up and stored off-site every single night. Meaning there's a gentleman that comes, or a lady, whoever it is the company has come, picks up a case from the IT department every night about 6 o'clock of that day's data, and it's stored off-site. And one of the reasons for that is, God forbid, if the entire campus was to have a catastrophe of a tornado or whatever the case may be, we would have data, could restore that data within 48 hours. We also have a HP campus in Colorado where we actually test this every year. We spend about 4 days and have somebody at full-time that writes a grant for $1.5 million for this backup system, this disaster backup system. And we've had it for about 12 years. And they go to the campus in Colorado, take the backup tapes, and restore them within 24 hours. They have locations here in site in Rockford where they restore here as well. And they set up all the student data records, all admissions, phones, all the systems are go within 48 hours. And we do that every year, and we've done it again for the last 10 or 12 years. Now, do every company do that? No. Can every company afford to do that? No, we couldn't afford to do it if we didn't have a grant for it. We definitely couldn't. But companies can, by the way, write grants for what I just mentioned. The government wants you. They know it saves the government money if they keep you going than if you're down for a time or you totally lose your company altogether. That means jobs, people are going to have to be displaced, get other jobs. So there is grant money to help. So it isn't cheap. It is not cheap is my point. But we'll talk about this semester, which networks help as well in disaster recovery plan. It's kind of those things you hope for the best, plan for the worst type thing, right? None of us want the worst to happen, including myself. I'm a pretty positive person, but things don't always go right. Things don't always work right. And so stuff happens, right? And so workstation, that's your personal computer, or actually the server, I forgot to mention, it runs differently than a client, its own operating system. The client has its own operating system as well. That might be a misnomer coming into this class is you think it's the same operating system. It's different. And so that different operating system is important when it comes to networks. So elements common to both client-server network or common to a client-server network is a NIC card. A NIC card basically is plugged into the back of your computer. These computers all had new NIC cards put in over summer. Our old ones were going bad. As you can imagine why. We're always plugging and unplugging and plugging and unplugging all the time. NIC cards all the time, and our Cisco classes in here. So the NIC card basically allows you to connect your computer to the network via Cat5 cable in our instance. There are NIC cards, though, for fiber, though. There are NIC cards for wireless, all three. Network operating system we already talked about. It's a server software enabling the server to manage data, users, groups, security applications, and other functionalities. So here's a NIC card up close. You'll notice in this picture here, when I'm circling with my mouse, this is actually the highlighting the MAC address. You might be familiar on a car. You've got a VIN number, right? This is the equivalent of a VIN number because it's unique to that manufacturer. It's comprised of different things: a manufacturing ID, a random generated number for that manufacturer, and usually some type of prefix or suffix that includes it in there. But it's unique to the network. And the reason for that is you have different manufacturers, right, that create NIC cards. They all work together to make sure their NICs are all different in their communication, just like your vehicles should all be different in the VIN number, right? Wouldn't be good if they had the same VIN number trying to go, Department of Vehicle and Motor Services and try to get title for the car. Two cars have the same VIN number. They probably frown upon that. I'm guessing they probably wouldn't like it too much. And so, same thing with networks. And then also second reason is for communication purposes. Networks will communicate via your NIC card, and it knows one of the ways it communicates is via that MAC address. And you'll learn this semester some things you can do with a MAC address, like you can, on your home network, you can limit only certain devices on your network that have a certain MAC address, and no other MAC address can come in to kind of safeguard your network from anybody trying to glom onto it. So easy stuff like that you'll learn this semester. So host, that's an old term in networking, but it's still around. It's basically where it's technically defined as a computer, as a host. And a host can be enabling network resources by other computers. Node is a client server or other device, and it communicates over a network. It can be a mobile phone, it can be a tablet, which are the top two most popular devices in networks today. In fact, they surpassed sales, tablets and phones surpassed laptops and desktop sales a year ago around this time in the history of computer sales. And so, which probably doesn't surprise you, because if you think about your day, you're using your mobile device probably much more than any other device when it comes to communication, right? So I already talked about the unique number on the MAC address. There's also and it uses that, by the way, on this case, from the network address, which is assigned by the network operating system. Connectivity device. This would be like your Cat5 cable, your Wi-Fi, your fiber optic. Elements common to client server continuing. Segment, a group of nodes connected one to the other. So this room, everybody in here, all your computers would be considered nodes in traffic on the network. Backbone refers to what does your traffic rely on for data transfer. In this room, it's Cat5, but we have also in this room a fiber cable that runs under the floor all the way to the Cisco lab. We have a 3-foot clearance in each floor in this building. In fact, all the buildings do. And we run all of our cables in the floor versus the ceiling. A couple of reasons for that. It's more secure because it's harder to get access to floor tiles. Like in this room, you can't even get to it. There's only certain rooms you can lift up floor tiles to get into the floor. IT is one of them. You literally can pick a suction cup and pick a floor tile up and jump down in there and work on cables, which nobody likes to do. So, but you can do that if you want to. And I've had to do that before. And so, but there's enough clearance to work it out. So backbone in this network on campus is we have two backbones, actually, that our network falls upon for work, student and faculty, and that is Cat5 and fiber. Now, Wi-Fi is a part of our system, but it's not technically a part of our backbone, okay? Backbone is generally going to, again, be considered the workhorse of the network. And all computers on campus, RDC-owned computers anyway, are on the backbone, which I've just mentioned, which are Cat5 and fiber. Topology, that refers to, and you'll play around with topology tonight in your handout when you do your group stuff, is different layouts. You have ring topology, bus, star, and hybrid. So here is a backbone I referred to earlier, and you'll notice it's encompassing the entire network, and depending upon the wires used in your network, depends upon the backbone. Here is the components of a topology. We'll start with the oldest first. Upper left, a bus network. The bus network actually used, how many has Xfinity cable or some type of cable system in your home, or you've had it before? Okay, it uses coaxial cable, and coaxial cable was the very first networking cable that we had. Okay, you'll notice on the coaxial, on the upper left corner, it looks a lot like coaxial cable, those lines do, right? And the NIC cards actually had a little place to twist in that coaxial cable. And it was just as fast as our Cat5 today, but as you can imagine, a little bit more expensive to make the Cat5 because the Cat5 cabling is much cheaper. In fact, it's on your table around you, the little white cables, as far as the cost to create the sheathing, the metal, the wiring is much less cost factor than the coaxial cable. And when we do the lab for our cabling lab, I actually break down the cost of every cable and how much it costs per feet in today's dollars. Okay, in today's dollars. So lower left is the next in the life cycle. They came around the same time. Is a ring topology. The way this works is, and you'll notice it's like a ring in the middle, and all the computers are connected one to the other. The way it works here, if you look at my monitor here, you've got. We'll pretend this computer here has some data, and it wants to send it to this computer here. What's going to happen is, in a ring topology network, it duplicates. If it's a 5 meg file, this computer is going to get 5 meg file. This computer is going to get 5 meg file. Then it's going to. We'll say it's going to cycle this way to the left. So then it goes. This computer 5 still has 5. This has 5. This has 5. Then finally, this one gets it. This one still has it. This one still has it. This one still has it. When this one on the network sees that this one has the data, then and only then is the data here and here dropped. So there's a lot of redundancy in a ring topology, but there's more surety that the data will get there. We're going to watch a video next week that explains more how data can be dropped. It's pretty complex, but it's simplistic in how it happens and why it happens. But out of all of these 4 that we're going to go over tonight, these 4 topologies, a ring is the most sure way for data to get. And so banking facilities, military facilities, the stock market uses ring topology still today. A lot of ring topology networks will have 2 NIC cards on every machine, one for input, one for output. Okay. A lot of the client servers here on campus, a lot of our servers in our IT lab, our IT room will have 2 NIC cards on a ring topology as well for redundancy and to make sure data gets there. Now, that doesn't mean speed. That just means data is going to get there more assuredly than it would with just the one traffic from one computer to the server. Upper right corner, the star. We're in present day now. If you're to build a new computer lab today or new in any business, have to buy computers, the top right's what you're going to normally set up. If you were to call Entree Computers, or if you were to call High Comics or any computer place here in town, the networking professionals to set it up, or if they were to call me to set it up with a group of people, I'd recommend a star topology. That's just because, number one, it's more supported technologies today than the 2 I just mentioned. Most modern technology in all of the systems that are out. And it's fairly easy to set up and easy to grow. Now you'll notice on this one, it's got 4 computers. In fact, all these just have computers. There's no server represented, but in a client server architecture, you would have a server in that piece as well. But do note in the star, different than the ring and the bus, every computer now is connected to an intermediate device. So if one dies or crashes, it's just a matter of replacing it. The lower right is what you'll normally walk into if you're in a business that's been around for 20 plus years. They've seen all of the life cycle of topologies. An example, Ingersoll. A number of my students have worked there over the years and still do. If you go into Ingersoll, if I was to take you on a tour, I could show you every single topology in here that's on this sheet. And you say, well, why don't they replace it? Because they work, right? They still work. There's nothing wrong with them. So yeah, they still have topologies running on coaxial in Ingersoll. They still have topologies running on coaxial in the old Woodward Governor building that's in town. Now the new building that they built on Perryville, oh no, that's all star. That's all star topology at that building. It's all brand new, which has been built in the last 3 years. But so when you walk into any IT facility or any banking, educational business has been around, manufacturing, which is this region is good for, you're going to see a hybrid. So the reason I say that is I have a student from my 130 class that showed me a picture of a computer. They just retired this computer, right? It was a Dell Latitude, or no, Toshiba A Toshiba satellite laptop is one of my, it's like my third laptop I had. Two floppy disks. It was still being used up till last month at that factory, okay, on a certain device and being used to store data and retrieve data. And so they finally upgraded replaced the system, and so they're having to get rid of the laptop. He showed me a picture of it, and I'm still collecting stuff for my museum, which one of these days I'll have time to put together a computer museum. I said, hey, can I have that? And he said, no, they already destroyed it. So most companies will do that, by the way. But the reason I mentioned that was that's modern day. That just happened yesterday. So that computer there, by the way, that he showed me, connected to that device in that shop via serial cable. It didn't even have a Cat5 cable. It wasn't made for a Cat5 cable. It was a serial cable, which is very old school. Really dates me. And so, so anyway, let's go on to the next slide here on different types of common elements in a client server. Protocol. Protocol will be standard between different formats of communication between two network devices or more. Data packets is, I like to call them like cabooses on a network, on a train, is your data packets that can be transferred however the network server wants it to be sent. Addressing is a scheme for assigning unique identifiers for every node on your network. The network will assign a network ID. And then transmission media, already went over that, the different types, which would be Cat5, fiber, and Wi-Fi for the most part. Here's a screenshot here of the different types of most popular backbone media. Coaxial, and you'll notice here the copper type inner piece, the plastic tubing here, the metal sheath a lot of them had originally, and then a hard plastic covering there. So a lot of material here that's pretty expensive. Going to the twisted pair that we actually do in class here in a few weeks. Okay, these wires are very cheap. Then it generally has a piece of cloth that runs out of here, and then some type of very, very skinny wire here or covering here. A lot of times it doesn't even have that. It just has a cheap plastic covering here, and that's it. And then the fiber optic, we'll talk more about this semester, but can either be glass or plastic, either one. And again, hard or flexible, fairly hard, flexible material here. And then more, sometimes metal, sometimes plastic here. That's kind of a net type of environment. And then the sheathing here can be different depending on if it's oceanic fiber, meaning literally running under the ocean for thousands of miles, or running underground. So a new subdivision, right, built in Rockford, is going to use fiber all underground for all of its networks. So when Xfinity drops a line in that network or in that neighborhood, it's all underground. But also is your electric's all underground in new subdivisions, right? There's no telephone poles. Everything's underground. So depending on where it's used, fiber is going to be at different grades of covering depending on where it's used underground. Next is radio waves. Here on campus, before they built the nursing center, I don't know if any of you remember the satellite farm that we used to have out back here. Over when you left the WTC to the right, we had about 18 satellites, right? And these were radio dishes that were pointed to different locations in the region. We used to use them years ago for a lot of stuff before broadband internet. We would use them to teach classes across the state within Rockford via television. We would have a camera in the room, and it would beam it to another location, and we could teach a class, be here, but teach a class in, Springfield, Illinois, or teach a class in downtown Rockford with that. Now, what they did with all those dishes is if you drive down down Mulford, keep driving down Mulford, keep going and going and going till you get to the end where Perryville is. If you look further out past the Perryville Road there, you'll see a whole bunch of towers, they look like cell towers, really. It's in that little area that we put all those dishes, the 18 dishes. So there's still some of them being used, but that's where they're all used, moved to.
One thing off of Mulford,
Yeah. Yes.
the little gated area thing.
Yeah. That's yep.
That's what it is.
Yep. Now this radio wave, you'll notice it's pointed. Again, this is just a visual example here. It has it pointed towards a computer, but normally a radio wave would be pointed like Rock River Internet downtown Rockford uses these dishes on top of their buildings, right? Where companies can share internet cost with these type of connections. And this was before any of the newer technologies, but they still work. And so they still are using them and much cheaper to use. Network services, how they're used. So first you have email, which is most visible. Everybody's familiar with that. So when you check it, go to work in the morning or at night, you might have email that comes to you from HR, from your boss on the tasks that you're supposed to do. Other services that networks provide would be print sharing, file sharing, internet access, website delivery, where like here on campus, we have Rock Valley College web server that serves. It's actually a server here on campus. And when you go to our website, it actually is serving it from a server here on campus. Voice over IP. Here on the corner of the room, we have a voice over IP phone that's plugged into a Cat5 plug-in up here. So it converts digital to analog. When we do the tour at the end of the semester, I'll actually show you a really cool room. I call it the broom closet. That people don't like what I call that, but that's what I call it. Anyway, what it is on one side of the wall when you walk into it, everybody know at your home you have a basement where you've got the analog lines coming in from your home? Everybody seen that before? It looks like a really ugly wall, or like an ugly mess of wires, really. You're like, how in the world do they figure out where those wires go? But the wall is about as big as that wall there, okay? And it's totally full of those little bitty analog wires, those telephone wires, old POTS lines, what it's called. That's when you call the campus, it hits those wires, okay? Goes underneath the floor to this wall over here. It's all converted to fiber. It's got fiber patches. So analog is converted to little boxes and then to fiber patch. And so when you call into the campus, it goes under conversion boxes, fiber, to servers, to all the phones on campus. These phones can actually be connected to computers, and they are. So the way it works in here, in most offices, Cat5 is connected to the phone, then another Cat5 is connected to the phone that's connected to your computer that powers your computer for internet network. But what's cool about it too is there's special software you can put on your computer that when somebody calls, it pops up their face on your computer and the last time they called you and information about them. That's how customer service folks do that when you call them about your account. You're like, how do they know who I am and what my whole history is about? I just literally called them through voice over IP. It triggers your number as a unique field in the database that you are, John Smith, and here's your record and your last call, and how can I help you? Did we take care of the last problem you had, which was X, Y, and Z? Oh, I see we took care of that. What can I help you with tonight? So that's all done via voice over IP. That's a vital network service today. File services. We can have large bits of data all over the network. Here in Rockford, manufacturing hub, have a lot of manufacturing firms that will use AutoCAD, and AutoCAD files are really large. An average AutoCAD file is about 4 to 5 gigs in size. That's a small one. And so those going across the network all the time, as you can imagine, can really, really, really bog down a network if it wasn't set up correctly. And so file services help with that. Print services, printing from everywhere across the network. And then finally, remote controlling computers at moment's notice to help them with help desk issues, remote controlling to set up and configure a network or to show them how to do something. 2, logging in via a WAN connection to, say, the Stenstrom Center to help an instructor over there or to help a student to do their work. So I'm going to skip on to the next part of the internet services. So internet services, you guys are familiar with internet providers right at home. Internet services, when it comes to network, basically is about hosting a web server is what it's about. Hosting a web server to where you can push your website to the world, right, via internet services. That's built into the network operating system. Managing services like small network management, large network management, also built into management services. Other important traffic and services would be like load balancing, traffic monitoring, hardware diagnostic, asset management of every device on your network, licensing traffic. There's some software that says, okay, we can only have 50 seats available of this license, but we have 100 employees. And what that means is 50 people can connect to the software, but when the 51st person does, the software will say you've reached a limit, wait for somebody to get off. And that's available on a network. The network operating system can track that. Security auditing can track how many people has weak passwords, when the last time you changed the password, every website you've been to, every file you've clicked on, every traffic that you've done on your network or on your computer can be traced in auditing. And then address management, IP management, MAC address management, network ID management, and then backup and restoration of data. You're constantly in IT having to back up and restore files that people delete on accident. I deleted a file. Can you restore it? That happens all the time. And backups help us do that. So lastly, before we go to our lab, let's talk about job market. Anybody like to have a good job, or you already have a good job maybe? Anybody want to have a better job? Want to have a better job? Okay, if you want to have a better job, you're in a good field for it, whatever field you decide to go to in computers. It's so wide range of different things you can do. If you're a numbers person and love numbers and love math, you can be a network analyst, and all you do is crunch numbers all day on systems. And you could be maybe a security auditor, and all you do is, as a security auditor for IT, for a department in IT, is you assess everything in your network. You look at everything all the time. How people access your doors, how people log in, how people go in and out of your building, how people go in and out of your network. You're constantly assessing that and finding better ways to be more secure. Do people know what a secure password is? Do people know how to create a secure password and why they're secure? Do people know what links to click on and not to click on when it comes in their inbox? A whole slew of things. To a computer programmer, to a network technician, to an IT manager. So a whole bunch of different jobs. Cyber world, cyber terrorism, cyber attacks. If you're interested in that type of stuff and thwarting that type of activity, huge field in that area. Mobile app development and deployment and security and management is a huge one as well. Where basically now there's tools in mobile apps to where, as a company, I can set up what's called a mobile app management system and control every device that I have in my company, install any app I want to at any time on all the phones from one click of a button, and I can see all the traffic on all those phones, where they're going, where they're at physically, locationally in the world, all from one location. Couldn't do that 2 years ago. Now you can. And there's companies sprouting up all over that needs expertise in those areas. And if you're interested in that, that's a whole field, new field in the last 2-3 years that's growing like gangbusters, right? And it's going to continually grow. So the job market's full. A lot of postings are out there. You'll learn more about that this semester. That Tech Expo, you'll learn tons about it. Dice.com is a popular one I recommend to students. LinkedIn. If you don't have a LinkedIn account, get a LinkedIn account. That's the #1 job source for IT folks today is LinkedIn. And the reason for that is LinkedIn has every known company known to man are on LinkedIn. And when they hire for jobs now, they are the #1 place companies post today is LinkedIn. So for no other reason to get a LinkedIn account, get it for that reason, okay? Because you can sign up to LinkedIn, totally free, start following companies that you'd like to work at someday, and who knows, you might just do that. I've got students at Rock Valley College that I've had over the years that work at Microsoft, they work at Google, they're developers in Apple in Cupertino, California. And I talk to them on a yearly basis, and to keep up with how they're doing, you could do the same. There's no reason why you can't do it. You can do the very same thing. So there's no limits, basically. So the only limits is what you put on yourself. And so LinkedIn will be a great launching board for some of you to, or actually for all of you, if you get on the ground level now, start building a profile. You can look at my profile if you want to, see how I've done it. Connect to companies throughout Rockford, and I can help you with that if you want. I've helped a lot of people do that. And so, but out of all the social media platforms, LinkedIn is probably the one that most students know the least about. And so LinkedIn is probably the most important, though, that you need to know the most about. You know a lot about Facebook or Twitter, which are, great social media platforms. But as far as getting a job or keeping a job or having a great network of people you can get help from, LinkedIn is the best place to go. So I can't stress that enough. So job market, expertise levels will vary today. Preparing for the job market, you need to master your skills, select whatever interest you might have. And I know it can change when you start in college. Mine did. Study them. You're constantly learning and growing in IT. I go to multiple events every year to keep myself on the cutting edge of stuff. And it's constant. So what you learn at Rock Valley is just the beginning of kind of what you're going to learn the rest of your life. You'll be doing it all the time in this field. Whatever facet of IT you go into, you're going to be constantly learning. And for me, I don't know about you, I like that. I like to learn new stuff. I like to learn new technologies and ways people can do things better, including myself. And when you see a person do something better and it helps their life, whether it be productivity or whether it be making more money or more time with their family, what's wrong with that? That's great, right? And so I'm all for that. And so technology, I believe we should use it and be on the bleeding edge of it to help us in whatever market we might go into. So mastering your technical skills can take time. It takes time. This takes years of experience, but also one of the ways you can do it is getting certifications. Tons of certifications are out there. Nothing beats hands-on experience for sure. And I encourage you while you're on campus, when you see postings on my RBC this semester, which you will, when you hear of jobs, when you go to the RBC Tech Expo, which you will, take that opportunity, right? You're like, I've never done it before. That's why the interns are there, for you to get experience, right? In whatever area it is you want to. But that experience is going to help you in any type of job, every job that you might think it would never help you for. What I mean by that is you could do an internship for, I don't know, we'll say Lou Back Row, taking trash out to the trash dumpster, and you're doing an internship and you're doing maintenance for Blue Back Row, but maybe every once in a while they let you set up a printer or whatever, but they don't have enough for you to do to keep you full-time or part-time even. So you do some maintenance stuff on the side, right? We'll say that's your job. And I'm just picking that out of a hat, right? That's your job. Well, you graduate Rock Valley. The guy that you worked for at Lou Back Row now works for another company that needs an IT manager for the entire firm that he's working at. Guess who he's going to call first? You. Your name's going to come to his mind. You graduated Rock Valley. You were a good worker while you were there. You did everything you were asked to do, and you were very intelligent. You wanted to do whatever you could do to learn. You're going to be at the first call for sure. So that little bitty insignificant internship that you thought was really nothing and really didn't get any much from it, now is landing you a job 3-4 years later that you never would have gotten if you didn't do that internship. So think of it that way. What you do now will be planting seeds for what you will do later, if that makes sense. And just like a tree or a flower, it takes a while for that to germinate and grow, but it will grow. It'll happen. Be patient with yourself and with the process, and it will happen. Hopefully that encourages you. So soft skills. This is huge. When I first started in IT, has anybody watched Saturday Night Live? By the way, you ever heard of? Everybody never seen Saturday Night Live. You've never seen it. You have? Okay. Well, everybody heard Jimmy Fallon. You heard of Jimmy Fallon? Okay. He used to be on Saturday Night Live years ago. He still goes on once in a while, even though he's a late night big guru now. But he did a thing he did a skit on SNL called Nick Burns, the Computer Guy, is what it was called. And if you get a chance to watch it this weekend, it's hilarious. But he would come into a room, people have a problem like, Nick, I can't get something to happen on my computer, nothing works, can't print on. He'd go over and look at him and go, move, and he'd come over there and go, was that so hard? And then as he would walk out, he'd look back at him and go, you're welcome. Okay, those days actually used to be like that in IT, believe it or not. Okay, many of you don't remember. You're not old enough, but, was the one point we could get away with that. Not anymore. You have to have soft skills. You have to be able to be nice to people, right? You get treat people like that. Now, will everybody have awesome soft skills and be able to talk to people and just shoot the breeze? No, but everybody can do better, right? We can all do better in having our soft skills. So very important to understand that teamwork, customer relations, and getting stuff done like that is important to getting an IT job. So soft skills is important. So what we're going to do now is I'm going to go cancel out of this. Close my recording.